So minus 10 root x.
Yeah, hold on. Let's write this out. So that's the same as 5x to the half. How about this one?
10 to half x. I'm not too sure.
That's x to the minus 2.
Okay.
To bring it up, and then this one's all right. Okay, let's differentiate this one.
Minus 10 x to the half.
A half times 5.
Oh, okay, yeah. Oh, okay. 2.5 x to the half. Oh, yeah, or
Yeah.
half.
No, I'll leave this. Yeah, 2.5, 5 over 2. It's fine.
Plus minus 20x to the minus 2.
No. Subtract 1 from the power.
Oh, minus a half then?
That's it. Next one.
Okay. Minus 20x.
Yeah.
To the minus 3.
Well done.
And then minus plus 8 e to the minus 3x.
E to the x stays the same, this one. So minus 2x.
Do you know minus 1 from the...
The derivative of e to the x is e to the x. It's a special one where it doesn't change. Let's see. So 5 over 2. So they put that in back into that form. But they didn't ask for that. Minus 20 x and minus 3. Yep, great. Any questions there?
No.
Okay. Differentiate with respect to x. 1 over e to the 3x. How do you do that?
1 e to the third x.
This is the same as, not a third, minus e to the minus 3x.
Okay. And so that's differentiated in the first one.
So this is just e. That's just the same thing, and so now you'd differentiate it.
Minus 3e to the minus 3x.
Great. And so simplify this one down here and then differentiate it.
7e squared to the minus 3x.
Let's see. So it's going to be 7. And then what's the rule for multiplying index numbers?
They add, don't they?
Yes. So that's to the... So what will that be?
Plus 2x. Yeah.
So that's 7e to the 2x. And so now you would differentiate it.
14e 2x.
E to the 2x. Great. Okay, let's try these.
Eight x squared minus 1 e minus 6x.
Yeah.
Okay. And then 16x minus plus 6e to the minus 6x.
So let's check. 16x plus 6e to the minus 6x. Yeah, they didn't ask for it to be put back. Let's try B.
2 minus 2 minus 2e to the...
Hold on. Expand the brackets first.
Okay. 8 8e 4x.
Yeah.
Minus 6e to the minus x.
Yeah.
Yeah. And then from there on, 32e x, 4x, right? Minus plus 6e to the minus x.
Great. And they might write that as 6 over e to the plus x. Should be the same thing. 32 e to the 4x. No, they didn't this time. Plus 6 e to the minus x. Yeah, great. So, yep. Any questions there?
No.
Okay, how about this one?
Given, okay. So still differentiating e to the 4x.
Yeah.
4e to the 4x. And then from then on, I'm not too sure.
The 4x. It's equation of a tangent. What do you know about that?
I don't know.
It's a straight line, and so it's
Okay.
going to basically be y minus y1 equals mx minus x1.
Okay.
What is x1?
A half in this case.
So that's going to be a half. How do we get y1?
Is it the reciprocal?
You're thinking of something else. You're thinking of a normal. We want y coordinate.
Not sure now.
You sub it into the y equals 1. Y equals f of x. F of x is e to the 4x.
So y is equal to e to the 4x?
Yeah, and x is a half.
So e to the 2.
Yeah, so that's e squared. And so y1 is e squared. And how do we get m?
M is gradient, so is it x over y?
That would be GCSE, A level. How do you find gradient of a curve at a point?
I've forgotten.
It is so if you want y coordinate, sub x into f of x. If you want gradient, sub x into f dash of x. This is the gradient function. And so you sub that in. So y is the f of a half, m is the f dash of a half.
What's the difference between dash and no dash?
One is the original function, the other is the gradient function.
Okay.
F of x, f dash of x.
So in this case, is f dash to a half is m?
Yep. What is that?
I don't know.
So you sub a half into the derivative we just found. Derivative was 4e to the 4x.
Okay. 4e to the half? 4e to 2 squared?
Yep.
Okay.
And so its tangent is a straight line. y2 minus y, y minus y1 equals m x minus x1. They gave us x1 is a half. Sub that into the original to get the y coordinate. Sub that into the derivative function to get the gradient. And so let's make it y equals.
So 4e squared, open brackets, x minus a half minus e squared, close brackets minus e squared, or plus e squared.
Plus e squared, yeah. E squared.
So 3e squared. And then
Let's see. Expand the brackets just in case.
4ex squared. Yeah.
4e squared x.
And then minus 2e squared plus e squared. Okay.
And simplify it.
4e squared x minus e squared.
E squared. And so it's like m is 4e squared and minus e squared is like c. It's like y equals mx plus c.
Okay.
Let me just see that. Yeah. Hold on a second. Let's see old bookie. Pure 1. This was like 14.2, I believe. 2. So I want to see. Find the gradient of the curve. Okay. Yeah, hang on. Differentiate. Okay, it's a little bit simpler. Ooh. Let's try this one. Put it here. Okay, let's try question 7. How do we do this?
3e. So we substitute 2 into the x.
Okay.
The first one.
Right.
So e to the 6.
And what is that e to the 6 in this one?
We have to differentiate it.
Well, if you differentiate it, what would that give you?
6e to the
Hold on.
6.
Hold on. Okay, so what I'm getting at is e to the 6 is y.
Okay.
So what you got there was the x coordinate is 2 they gave you, the y coordinate is 6. So on that graph, when x is 2, y is e to the 6. When x is 2, what is m? So when x is 2, m equals, how do we go about doing that?
Y minus, is it like stuff we did before, so y minus y1?
Sure. What part gives us m?
Oh, okay. F of x?
F dash of x, derivative.
Okay. And to get that, you have to do... I've forgotten.
dy by dx.
Is it e6 over 2?
It is the derivative of the original function.
So 3e, okay. 3e to the 3x?
Yeah. And so you use that to get the gradient.
And x is the derivative of what?
When x is 2, what is dy dx? So sub 2 for x.
E6?
That's in the original one. That's what y equals. What is m equal to when x is 2?
3e. Okay, 3e6?
3e to the 6. Yes.
Okay.
3e to the 6. Let's say when x is 0, what is the gradient?
3e to the power of 0, so 1.
So it's 3 times 1.
3 times 1, so okay, so 3.
Yes. That's good. Okay, 1 second. Let me now. Other bookie. Pure 1. This one. 14.2. Oh yeah, okay. Find dy dx. Sure. Okay. It's all right. Okay, let's see these. These are the graphs. I'm not going to bother. Let me just see this. Hence or otherwise sketch the graph. I'll go back and sketch the graph if I have to. No, we better do it. Now, let's see if I can skip the sketching thing. Okay. Okay, that stuff so far. What do you give yourself? X a half or tick?
Half still, yeah.
Okay, so now same exact idea. They're just applying it to the real world. So instead of X and Y, it's T and P. Instead of just X in general, T is time or whatever. P is the density of pesticide. And the numbers aren't as easy as like 2 and 3. They're now kind of real world type of numbers. Okay. So any idea about this first one? Example 5.
What question are we answering?
Oh no, it's sketch the graph question, isn't it? Let me see this one. Sketch. This one. Yep. Part A for this one. Yep.
So 0.06 times 150,000.
No. When T is 0, what is V?
150,000.
Well done.
Okay.
It's basically 150,000 times e to the 0, which is 1. 150,000 pound. Yep. Okay. How about this one?
So minus 1 over 12. Does that mean it's not new at the moment?
When it's new, the time isn't 1. That would be after 1 year.
So 0 is when it would be new.
Yeah. When it's
Okay,
new, time is 0.
It's 20,000.
Correct. That's
Okay.
it. And so it's kind of putting it into real world context type of stuff. 20,000. Okay. How about this one?
Well, 20 plus 10e to the power of 2000.
It is T is the number of years after the year 2000. So time after 2000.
Okay, so it's 0 then.
Yeah.
So 20 plus 10, 30. Actually, no.
Actually, yeah.
Okay.
30,000 for this one. Because, yep, they're measuring it in thousands. Okay, how about this?
$200.
I believe so. And is this thousands or anything like that? No, it's just 200 people, is it? 200, yep. Okay. Looks weird. Should be the same. How about this?
$18,000 then.
18,000. Yep, I believe that's it.
Why is the 0? What does the 0 mean if it's down next to the P?
P0. It's just a P0. It's like initial P, something like that. Initial population. Sometimes they write it that way.
Okay.
I just, it's a real. Let me just go back. Yeah, so it's exam question, so I include it. Okay, how about this one?
Is it the amount of months in a year?
No. What was the meaning of the constant 18,000 in this one?
The initial population.
Yeah. And so meaning of the constant 12 in this one?
The initial number of rabbits.
Yeah, initial population of rabbits. Common question. 12 is the initial number of rabbits in the population. Okay, how about this one?
The initial density of pesticides.
Initial density of pesticide in the field. Great. Let's see. Okay, how about this?
So to find after 4 years, it would have to be e to the 4.
After 4 years, t equals 4. And so you need to get v.
Do you have to differentiate it?
No. And so what do you put into calculator for this one?
20,000 e to the 4.
Yeah, and maybe I'll just write it out. Hang on now, 20,000. T is 0, so it's e to the minus 4 over 12. So you just replace t with, you sub 4 for t.
I don't understand that bit.
Let's see, the value of a car is modeled with this. T is the age in years from new. So when t is 0, it's new. And so after 4 years, t equals 4. So you replace t with 4.
But why the minus t over 12? Okay, I thought that was a 1. I couldn't see from there.
Ah, sorry. Okay.
No problem. Why is it over 12 though? Is that just the formula?
That's formula.
Okay.
Do you know how to do E in the calculator?
I lost my white one recently, so I don't know if this one has E, but I'm not sure.
Yeah, it is shift long.
Yeah.
4 over 12. This is what I get. And so to the nearest pound?
Yep. 14,330. 1.
Yeah, 14331. And you have the calculator to hand, do you?
Yeah, it's right here.
Okay, great. Oops. Let me see. Let me just take a snap. 14331 down the bottom. Great. Stick that there. Okay, how about this?
$150,000 E 0.06 to times 7.
Yeah.
So I'm in the calculator again.
Yeah.
I got 228,294. Yeah.
Yeah, that's good to me. Oops. See. 228294. Great. I think you'd be fine for this. You just replace t with 15. Let's see this one. So what would you do with this one?
T becomes 6.
Yep. Then you just write it down. This one, let me see this one. T is 6. Great. Let's see. How would you do part A?
T becomes 1 in both.
Yep.
Okay.
Yep. And then you would just compare them. And then part B, T becomes 10 in both of them. And you compare them. So
okay.
It's all right. Okay. How about, what would you do? How would you do part A for this one?
H becomes 4.394.
Yes. And okay, any idea how you do? If we have time, I'll do D. Seems like it's quite a special question. I'll have to consider removing that. Okay, so what is T for this one in part B?
So if that formula is for the year 2000, it's 30.
So that one, T would be 30 and you would get P. How about part D?
No, because population varies. They're not always constant growth or...
Yeah. It would probably be some massive number, which isn't feasible. The population of the country to be over 220 million. This is highly unlikely, and by 2500 new factors are likely to affect population growth.
Okay.
Yeah, therefore the model is not valid for predictions that far into the future. Okay, how would you do part A for this one?
N becomes 1 in, and then it becomes 12 in the second one.
Well done. And part D?
Same as the previous one. It's not accurate when it comes to too large values, and other factors may affect the number of rabbits.
Yeah. Factors such as resources like food, space, that type of thing.
Okay.
This model will stop giving valid results for large enough values of T, as new factors are likely to affect population growth, such as the rabbits run out of food or space. Oh, there you go. Let's see this one. Okay, any idea how you do question C?
No, I'm not sure.
Basically differentiate it. dp, so instead of dy dx, it's just dp dt. Any idea what that would be?
So differentiate the formula above, so 160 times minus 0.006.
Yeah, 160 times, let me write it a different way. Just minus 0.006 times 160, yeah.
Minus 0.96, that's what it is.
Okay.
And that number is still to the power of minus 0.0060.
And don't forget the e.
Yeah.
Okay. There's a reason why I didn't multiply them. what is 160e to the minus 0.006t the same as?
160 over
No.
minus.
From here. So what is 160e to the minus 0.006t equal to?
P.
Yes, and so that whole thing you can replace with p, and it becomes minus 0.006p, meaning let's say you wanted the derivative gives you the gradient of the graph, so basically like the rate of change. So this looks like the density of pesticide is kind of like decreasing over time, something like that. In the beginning it's falling very quickly, and then towards the end it's falling very slowly. This will tell you the rate at which it's falling. So early on the rate will be very negative, later on the rate will be less negative. The way you would do that is whatever its current p is, you would multiply it by minus 0.006, and that would be much quicker than having to put it in there.
Okay.
Interpret the significance of the sign of your answer to part C. Any idea what the sign of this answer tells us?
No.
It is exponential decrease, exponential decay.
Okay. So for C, K is what number then?
K,
minus 0.006. Okay.
Yeah. K equals minus 0.006. Yeah. So if you want to know at what rate the population is decreasing. K is minus 0.96. That was your number. Let me see that. Times P. No, they're wrong about that. K is definitely minus 0.006, isn't it? So the derivative is that times 160. That is P. Yeah. I think, well, we'll see how we do. Yeah, you made a mistake, Book. Book made a mistake.
Okay.
And so it makes it much quicker and easier. Okay, all right. How about question B?
Okay, so minus 0.15 P.
Correct. You got there quick. And so K is minus 0.15. Interpret the sign.
Say exponential decrease.
Yeah.
Of the dose or level of paracetamol.
And you can just say exponential decay or exponential decrease.
Okay.
What if it was plus? What if it was positive?
Exponential growth.
Yes. Exponential growth, exponential increase. K is negative, so the amount of paracetamol in the body is decreasing. Yeah, there you go. K is minus 0.15. So that this previous one, I'll just make a note to myself. That one, it's a misprint. K equals minus 0.006. Oops. 0.06. Yeah. Good. Alright, we'll just do... Yeah, I'll do this one just in case.
Minus 0.13 P.
That's great. And C?
And C would be exponential decrease, is that, or decay?
Yep.
So significance means the pattern of it, or the trend?
I don't know. Interpret the significance of the sign. So basically, what does the sign tell you? If the rate of increase is negative, then it's not increase, it's decrease. Basically.
Okay.
Like if the % of money you have in your bank account is negative of what it was last year, then it's going down. basically. The atmospheric pressure decreases exponentially as the, yep, fine. B minus 0.13. Okay, part B for this one.
Minus 0.12 V.
Great. And what one to use too?
So what does that give us? Minus 0.12 V?
That gives us dv dt, but now we want dv dt when t is 2. Any idea how to do that?
Do you square it?
No, I think... Well, how would you find dv dt when v is 2?
Cancel out these. Probably right.
No, you would just sub 2 for v.
Okay, yeah, okay. Makes sense.
When t is 2?
Substitute.
Let's just do the long way. It's kind of misleading that they did that. So minus 0.12, and then it was times this v. What v is equal to?
29,000 E.
And so when t is 2, how do you get dv dt when t is 2?
I don't know.
You substitute t for 2.
Okay.
Or 2 for t. And so it would be 2 times 2 basically. And you'd get your answer. How about this one?
Same but with 6 then?
Yep, so just sub in 6. Let's see. What a better question would have been when v is 2 and v is 6. Kind of rewarding you for differentiating it well. Use your answers to part A and B to describe how the value of the car decreases over the first 6 years of ownership. So will this be increase or decrease?
Decrease still?
Yes, and the rate of decrease is decreasing, I think. The value decreases over the first 6 years. The decrease happens more quickly at first and more slowly. Okay.
On the previous question. Yeah, this one. T, we substitute T for 2. But... Okay, I understand.
Yeah, the other way we could have done it is... So dv dt is also what you originally said, minus 0.12 v. You could have made t2 up here and then times your answer by minus 0.12. It's the same thing as minus 0.12 times what you get when you sub t in.
Okay.
Same thing. Let me see this one. Okay, any idea how you do this?
So m becomes 6.
Let's see. Yep.
Okay.
But that is this tells you the rabbit population. We want the rate of population increase.
So 12e 0.8. No, 1.2, sorry. 12e to the power 1.2.
That would tell you... okay. What is that? Put that
times. Yeah. From then on.
Just calculator. What is it?
39.8.
Okay, 39.8 rabbits or whatever. This one, does this look like increase or decrease?
An increase?
Yes. So after 6 months, there's roughly 39-40 rabbits. We started with the initial value of 12, but we want the rate of increase, like show that it's an extra 8 rabbits per month at 6 months. Any idea how you do that?
No.
It is the rate of change, dr by dm. And so what is the derivative of the original?
12e 0.6. No, 0.2, sorry.
What's the derivative of that thing?
0.2r.
Correct. 0.2 r. What is r after 6 months?
After 6 months, it's 40.
Yes.
39.8.
Yes. And so put that in your calculator. And it should be, go on.
7.96.
7.96, which is roughly equal to 8 rabbits per month. So this is 40 rabbits, but this is 8 rabbits per month. And so the rabbit population is slow at first, but it's increasing exponentially. So like people with the virus, very few at first, then suddenly it goes out of, it goes out of control quickly. So the rabbits, they start with a small population of 12, and they're probably increasing by 1 or 2 per month. But then at the 6 month mark, they're increasing by 8 per month, and it's going to increase by many more as you go.
Is this the best way to do it? So finding first, putting 6 as m, and then...
It's essentially the same thing.
Okay.
Yeah, it's essentially the same thing. I like this way because you get 2 things. Let's see. How would you go about this one?
So t becomes 0, so 150,000. Yeah. So.
Sorry. Question C.
0.06. 0.06 v.
Yeah. So that's 0.06 v. And then how do we do d?
So 0.06 v becomes 0.06 times 8.
V isn't 8, t is 8.
Oh yeah. 0.06 150,000 times 150,000 e 0.06 times 8, and then the same times 9.
Times 8. And my guess is those 2 numbers, a new property crash when it's increasing by 50 and 1,000 per year. And so those 2 will be in between 50 and 1,000. 0.06 times 150,000 e. Oh, this real world maths. 0.06 times 9. So my guess is the first one is a bit less than 15,000. Second is a bit more. And there we go. Bit less than 15,000, bit more. And so if it's...
Sorry, why was it around 15,000?
So they said a new property is going to...
Okay.
Yeah. So the previous one, show that it's increasing by 8 rabbits per month after 6 months. So basically when you sub in 6, the derivative is, 8, the gradient is 8. For this one, when you sub in 8 or 9, the derivative is close to 15,000.
Okay.
And so it's a bit less, a bit more. So it's in between those. Great. Got it. And so exponential modeling, what do you give yourself for those ones?
Uh, almost a tick, but I feel like I need a bit more practice for it.
Yeah, that's good. And so what you could do next is like logarithms, which is the opposite of exponentials. But yeah, how was that for you, Hugo?
No, that was good.
Um,
So this is maybe how much would you have? How much in a chapter did we do today of that chapter?
let's see. So we did, that's one section, exponential modeling. I kind of skimmed over graphs. So we did two sections. Yeah,
Out
four
of how many? 10?
out of this logs. Well, you did pick the last chapter. Let's see. Logs solving. Out of 6. 2 out of 6. Not bad.
Okay,
Yeah, you couldn't get more efficient than that. You did great.
that's great. Now and yeah. So next week, just finish this chapter.
Okay. So continue with this one. We need to figure out times or whatever. Your dad can, or is this time good for you?
Yeah, it was good for me. Just I should have checked Skype before, but I didn't know that I had the lesson until 3 or 4 this afternoon, and I had lessons, so I should have checked before, but I didn't know.
That's all right. So I'll put this time in calendar. Grant. Yeah, and I'll send you the notes and stuff. Any questions for me in general?
No. Thank you again.
All right. Well done, Hugo. You did great. Good seeing you again. And
Yeah,
I look forward to chatting again next week.
great. Thank you for everything. See you next week.
All right. Have a good week. Goodbye.
You too.